Hello. Today I am here to discuss about two problems related to Rainman problem. First question: a bus is moving uphill on a slope inclined at 30 degree with a constant speed at 72 km per hour. At this time, rain is falling vertically downward with a speed of 6 meter per second. When the rain almost stops, a horizontal wind starts blowing. Determine the angle at which the bus driver initially sees the rain falling. So in our first case, we need to determine the angle at which the bus driver initially sees the rain falling. So in this case, the bus driver what you need to find out that the bus driver need to determine the initial rain falling, in the case of initial rain falling. So I will draw a figure. Moving uphill on a slope inclined at 30 degree. That is the slope which is inclined at 30 degree with a constant speed of 72 km per hour. So here is the bus. This is the bus. Okay. We need to first convert the 72 km per hour and 6 meter per second. So 72 km per hour divided by 3.6 is 72 divided by 3.6 is 20 meter per second. So bus is moving at 20 meter per second and on a slope inclined at 30 degree with a constant speed. At this time, rain is falling vertically downward with a speed of 6 meter per second. Rain is falling downward with a speed of 6 meter per second. Wind initially there is no wind, so in this case horizontal wind starts blowing. That will not be applied in the first case or in the first problem A. Okay, so so for simplicity I can draw this. This is one which is 20 meter per second, which will be 30 degree from the horizontal with the horizontal, and this is 6 meter per second. So the velocity of the bus VB vector is equals to 20 cos 30 degree I, okay, plus 20 sin 30 degree J. So if I calculate this, ten root 3 I 30 degree, and it will be 10 J. Okay. For rain VR, that will be minus 6J, because the rain is falling downward. The rain is falling downward. In this coordinate system, there is I minus I, there is J minus J. So rain is falling downward. That means VR should be minus 6J. Okay. Now I need to determine the angle at which the bus driver initially sees the rain falling. Okay. So I have to find out the velocity of rain with respect to bus. The velocity of rain with respect to bus, VRB is equals to VR velocity of rain minus VB velocity of bus. Okay. So velocity of rain is something VR is minus 6J and VB is minus 10 root 3I minus 10J. Okay, so fine. If you calculate this, 10 minus 10 minus 6 minus 16, 10 minus 10 root 3I minus 16J. Okay, fine. So in coordinate system the point should be the point should be minus 10 root 3. So minus 10 root 3, here is minus 10 root 3, minus 10 root 3 I, and here is minus 16 j. Okay, so that will be the point, and the direction should be this, that is the resultant, or that is the velocity of rain with respect to bus, relative velocity. Okay, I need to determine the angle with the bus. So here the angle should be 10 root 3, tan theta is equals to 10 root 3 divided by 60. So theta should be 10 inverse of 10 root 3 divided by 60, 47.27 degree. Okay, fine. So 47.27, and here is the 47.27 angle is with the vertical line. Okay, so this is the theta, 47.27. So we need to tell that what is the direction, because they determine the angle at which the bus driver initially sees the rain falling. So theta is equal to 47.27 degree with the vertical line. Okay, fine. So we have done A. Now you have to do number B. Okay. So for number B, calculate the magnitude and direction of the wind such that the driver sees the rain falling vertically downward. In this case, yes, I need to draw the figure again. Driver is moving in this direction, 20 meter per second speed with an angle 30 degree, right? And we see that the rain is moving vertically downward. The resultant will be vertically downward rain. We see that means after all those calculations we get that the direction of the rain will be vertically downward. After all of those calculations we will get that the rain is moving vertically downward, or the rain is falling vertically downward. Okay, the resultant should be this. So I will say the resultant velocity vector after later. We need to figure out that from which direction the wind will be moved, or wind will blow. So when the rain almost stops, almost a horizontal wind blow. So in this case the wind will blow in horizontal direction, in this direction, or in this direction. Okay, so if the wind blows in this direction and the rain is falling in this direction, okay, so wind is blow, and then resultant should be this something, and the result will not get any kind of near any kind of those values. Suppose that the actual or the final result will give that the rain will blow in horizontal direction. Okay, fine. So in that case the rain will blow in this direction. I will do the math and explain. After that, explain that the rain, wind cannot move in the opposite direction. So, in my sake, I just write it that the wind will blow in this direction. The direction of the wind, VW, will be in this direction, and we need to figure out the magnitude and the direction of the wind such that the direction. Okay. So first, what is the resultant velocity? Resultant velocity is V R. V resultant R, or resultant rain. V rain with respect to driver V, rain with respect to D, or I could say B or D, anything you could say. That is VR minus VD. What is known about VD or VB? Okay, let's write it VB, because I have already written it in the previous case. VB is 10 root 3 I plus 10j. VB vector is 10 root 3 I plus 10j. Okay, fine. Now, what is VR? V rain. In this case, we can't just say that VR is as 6 minus 6j, similar to our previous case, but we can't say that because there is wind present there. So, and wind is blowing in horizontal direction. Wind is going in horizontal direction. So, in this case, if the I will say that this is number 1 equation. Okay. So if the rain is moving downward and the wind is blowing horizontal direction, this horizontal direction, VW, okay, V rain, I would say that capital R. We need to distinguish this R, a VR to VR. So VR. Okay. So if we extend this, then VR would be this direction, and the resultant or neat direction will be in this direction. Neat velocity will be in this direction, because resultant, which is VR. V small r, V capital R will be this. So what is V small r? V small r is the resultant R, which is the resultant of V rain and V wind, and V rain should be minus 6j, and V W or V wind should be VWI. Fine. So VWI minus 60j. Okay. So if we input this value in number 1 equation, we get that VRB is equals to VR VWI minus 60j, and VB is minus 10 root 3I minus 10j. Okay, fine. Then VRB should be VW minus 10 root 3I and minus 70j. Is it 60 or 6? It is 6. Okay. So it is 6. And that should be 60. 16. So, and if we draw the angle, and that is, I also need to draw 20 meter per second. This is 20 meter per second. 20 meter per second, and the resultant will be in this angle. To distinguish this, I need to, okay, the resultant will be this, and the angle it is making with horizontal vertical line, the angle it is making with vertical line will be theta is equals to 0, the angle, because in the first case if theta is equals to 0, the resultant will be in the horizontal line, in the vertical line. Okay, so the angle it will make with the vertical line will be theta is equals to 0. So now if we do the calculation, tan theta is equals to what we have just put in the previous case, tan theta is equals to in the upper case, that is I with the I part, and the lower case with the j part. The upper case with the I part, VW minus 10 root 3, and the lower case with j part, 60. Okay, fine. So now tan theta is 0, because theta is 0, tan theta is 0. So 0 is equals to VW minus 10 root 3 divided by 16. So VW is equals to 10 root 3 I, or I'm not doing this, 10 root 3 meter per second. Okay, 10 root 3 is approximately 17.32 meter per second. 17.32 meter per second. And what will be the direction? The direction will be positive x-axis or positive I direction. Calculate the magnitude and the direction of the wind such that the driver sees the rain falling vertically down. So our direction will be 0 degree from the horizontal or positive x-axis. Fine. Okay. So what would happen if we there could be a conflict that at you have taken in the direction in the positive x-axis, in the earlier case while doing this problem. What would happen if you take the negative x-axis direction? What would happen if you have taken the direction in the negative x-axis? So in that case, if we have taken it in negative x-axis, suppose there is the wind direction and there is the rain direction. Okay. So I need to extend it. There is the rain direction, and the resultant wind and the resultant rain direction should be in this direction. Okay. In this direction, the resultant, and the resultant should be in this direction. If we extend this, the resultant should be in this direction, and the direction of bus would be in this direction. Okay, so the resultant should be in this direction, and if you have seen the problem, or if you have gone through the basic maths, you should know that if the man's velocity in this direction and the rain velocity in this direction, or suppose in this direction, the resultant is always in between man and rain, in this direction or in this direction. The resultant should be always in between man and rain. Okay, that's why a man need to aim their umbrella on those direction. They need to aim their umbrella on inclined direction when rain is falling in vertically upward, vertically downward, and he is running. And they need to incline their umbrella before that. That means the angle should be in between 90, in between 0 to 90 degree. Okay, so in that case the resultant should be in this direction. there's no possibility or there's no possible case that the result could be vertically downward. But in our problem, the math has already told that the result should be vertically downward. The resultant value of the rain direction should be vertically downward. Okay, so that is why we have taken that the wind direction is in the positive x-axis, the direction of positive x-axis. I hope you understand. I hope you understand this problem, and we have to move to the next problem.
Okay, so in our next problem, question 2, we'll do this problem. Rain is falling vertically downward at a speed of 10 km per hour, and wind is blowing from east to west at a speed of 60 km per hour. Calculate the speed of a car moving from east to west such that both the front and rear windshields get wet. Only the rear windshield gets wet, only the front windshield gets wet. Okay. We'll do this problem related to the previous problem, the coordinate system process. So first we need to visualize the car and how the rain is falling and how the phenomena is going around the car. So first, if we draw the car, this is our car. So rain is falling vertically downward at a speed of 10 km per hour. So rain is falling vertically downward at a speed of 10 km per hour. Speed of 10 km per hour. Rain is falling. And wind is blowing from east to west. So in our case, we'll let that at east to west. Here is east and here is west. So east to west wind is blowing 60 km per hour. We don't need to convert it to meter per second because all the values are in kilometer per hour. That at the velocity of rain with respect to car, RC is equals to velocity of rain minus velocity of car. So velocity of rain should be velocity of wind plus velocity of capital R, velocity of actual rain. This is the resultant velocity of rain. This is the resultant velocity of rain or net velocity of rain, and this is the actual velocity of rain, and this is the velocity of car. So first we need to VW. VW is what? Okay, fine. So to calculate this, both the front and rear windshields get wet. Front and rear. This is front windshields and this is rear windshields. And to get wet of those with windshield, the rain need to fall, or the rain need to move in vertically downward direction. Rain need to move in vertically downward direction. Okay, so rain need to move in the vertically downward direction to get weight of those windshields. So in that case, what should be the velocity of rain with respect to car? So we need to find out the angle. Okay, because they have given us the direction. So we need to find out the angle to calculate those things. So I want to draw the figure for A. Okay, so in this one, wind is blowing in this direction, rain is falling in this direction. So what is the velocity of car? Then that's why the rain will move, or resultant rain, velocity of rain with respect to car will be in this direction. This is VRC direction. So velocity of car is in the in this direction. So we can say that VW bar is wind is 60 km per hour, or 60 I, plus VR is 10, VR rain is minus 10 J, and thus VC is VCI. Okay, so 60 minus VC I minus 10 J. So to be the angle with in this direction, the theta should be 0. It is similar to the previous problem. It's similar to the previous one. So tan theta is equals to, in that 60 minus VC divided by 10. 60 minus VC divided by 10. Okay. So for this one, tan theta should be 0, and VC should be 60. VC should be 60. This is the answer of A. Fine. This whole value should be 0. And for B, what would happen that if what does it say? Only the rear windshield gets wet. Rear windshield means this windshield. This is rear windshield. Rear windshield. Okay. So to get wet the rear windshield, I need to move this. I need to remove this one. So to get wet the rear windshield, we need to the resultant or the relative velocity should be in this direction. So to be in this direction, the theta should be this. This is the theta. Okay, so for this one, tan theta is equals to 60 minus VC divided by 10. 60 minus VC divided by 10, and the theta should be, theta is there 0 minus, theta should be minus. So tan minus theta is equals to minus something. Tan minus theta is equals to minus something, and you see that that is a range. The rear windshield will get wet, and that is not actual, that is not any actual value or actual direction. On this could be this direction, or this could be this direction, this could be this direction. On there could be a lot of possible way that the rear windshield can get wet. So we need to recall the problem of our previous one, that what is VRC is 60 minus VCI minus 10G. Okay, let's think that VRC is windshield, and this should be in this direction. The resultant should be in this direction. VRC or relative velocity should be in this direction. So what is this direction? Positive I negative j, positive I, negative j. So this should be positive. So 6 minus Vc should be greater than 0. Okay, so Vc should be less than 60. Fine, Vc should be less than 60 km per hour. Got it? For the next one, number C. Only the front windshield gets wet. So for the front windshield gets wet, relative velocity should be in this direction. For this one, the relative velocity or the velocity of rain with respect to car should be in this direction. Okay, so we need to write the equation again, this equation again. So from this equation, we don't need to write. From this equation we see that if the direction is in this direction, the I should be positive and this will extend in this one. So I should be negative and the j should be also negative. So I should be negative. So 60 minus Vc should be less than 0. Okay, so Vc should be greater than 60 km per hour, km per hour. So if the both front and rear windshields get wet, the Vc should be 60. If the front windshield gets wet, the Vc should be greater than 60, and if the rear windshields get wet, the Vc should be less than 60 km per hour. I hope you understand this topic. Thank you.